Welcome to Lean IT Foundations. Today we'll be covering Section 2, Systems and Tools, PDCA and DMAIC or DMAIC Methodologies, Part 1. This section will be divided into two parts. Section 2A, Part 1, Process Improvement, Systems and Tools, PDCA and DMAIC Methodologies. I am your speaker, Anthony McCollum, and I am a Process Improvement Specialist. Before we get started, let's just talk a little bit about why we are here. Over the course of history, technology continues to advance, almost in a linear fashion. But one thing that has typically remained the same is the way people interact with each other in those same business settings. Lean methodologies give us the opportunity to change the way people interact in business within their own organizations and help their customers to improve. And they do this through a systematic approach. Over the course of this section, Part 1 and 2, we will discuss two of these types of methods that Lean has introduced for us to better approach improvement in what we do. Before we get started, let's do a quick recap on Section 1. We spent quite a bit of time discussing what is Lean. We defined value as providing more value to our customers as the definition of Lean. We also talked quite a bit about waste. We understand what the 8 wastes are, and we discussed variability and how variability creates waste. We touched briefly on the history of Lean and talked about the Toyota TPS system, learned some Lean terminology, and watched a Kaizen video to see Lean in action. And we also discussed the differences between Lean versus Six Sigma. So a little bit about why we need a process when it comes to actually improving what we do in everyday business. Well, there's two basic things at play here. We have human nature versus an actual process flow for getting things done. Have you ever started a project and someone in the group said, I know what the problem is, and this is what we need to do to fix it? This is very common. And in fact, a lot of the times, those things that we feel that we need to do are correct, and they are things that need to happen. Sometimes when we start these projects, things are very apparent. It is human nature to jump straight into solutions when we live and work in an environment and feel that we see a problem every single day. When we take a process or a systematic approach to problem solving, the key difference here is we allow a bit of time to plan. That planning and ensuring that things don't reoccur by setting up a process and a system to manage itself prevents us from fighting fires when these problems do arise. It allows us to take a structured approach to make sure that we truly understand the problem, the root cause of the problem that we are trying to solve, so that we're not consistently attacking symptoms of problems. A lot of times when you're in that group, there may be one person that really does have a great understanding of the problem, but other people don't. And in most cases in business, in order to solve a problem, it takes more than one person. Sometimes we have to reach across business lines or boundaries, reach into other departments, work with people across the organizations that we would have never talked to otherwise. Taking a process allows us to make sure that we get the right people involved. Make sure that everyone has a common understanding of what the problem is, where the root cause of a particular problem is occurring. Another benefit to using a process or a method to problem solving is to be able to actually show the results of the problem that you have been working on and actually solve. Too many times we implement solutions to solve a problem, but we never had a baseline measurement. And when someone asks, well, how much better is it now? We don't have any evidence to showcase. The processes we will review today will help us to follow these systematic approaches to ensure that we're not fighting fires and that we can compare our befores and our afters against one another. The two processes we will review today is the PDCA, Plan, Do, Check, Act, and the DMAIC Methodology, DMAIC standing for Define, Measure, Analyze, Improve, and Control. We will spend much more time on the DMAIC methodology and have a quick review of PDCA. Let's dive into PDCA. The Deming cycle, or PDCA, standing for Plan, Do, Check, Act, creates a feedback loop for management to ensure that improvements are identified and implemented in a correct systematic approach. The first step, plan. The first things that we do here is actually select a project that we want to work on. Describe that problem. Make sure that we are actually getting down to the root cause issues of the particular issue. Set goals and create preparations for us to dive in and start improving whatever issues it is that we may be dealing with. Then you move on to the do phase in the PDCA cycle. This is where we actually get out there. We know what the problem is we want to solve, and it's time for us to dive in and start attacking that issue. We'll spend time gathering data, analyzing facts, and start to develop solutions. Once we have the ideas of actual numbers or facts of where the issue is today, the current state, and we've developed some ideas on what we want to do to improve that, we move on to check. And we actually test those ideas that we have, those solutions that we believe will help solve the problem. We implement those. We can implement them full scale or on a smaller scale to ensure that they are actually working. Test those solutions. These things can be done over the course of a day, a few days, a week. But it's important to actually put our ideas in motion and make sure that they are actually working. Once we confirm that they are, we can move on to the act phase. This is where we completely implement the solutions that we've identified, monitored them to make sure that they will continue to work, and continue on with the cycle. And that's really where continuous improvement falls into play. We never stop. We never end our strive to get better at the task that we are doing. Let's move on to the DMAIC methodology. DMAIC methodology, which stands for Define, Measure, Analyze, Improve, and Control. In part one of this series, we will cover Define, Measure, and Analyze. In part two, we will cover Improve and Control. This is a quick little cheat sheet or reference guide to the DMAIC methodology to understand what the objectives are, key questions, tools, and deliverables are at each stage of the DMAIC process. If you're working on a DMAIC project, this is a great sheet to have up in your workspace, in your area, on your phone, on your laptop, to just see where you're at in the process, just for a quick reference to make sure that you're on track. Feel free to reach out to me for a copy of this process improvement guide. Let's jump into the define phase. In the define phase, there's three key things that we're going to cover here. Creating a team, developing your problem statement, and the beginning of what is called your A3 project charter. So let's talk about our team selection. If you're working on an improvement project, you should be working with a team. It's extremely difficult to implement solutions or improvements within an organization without the correct team members. Some of those team members that you should have on your team is a sponsor. A sponsor is going to be a higher level executive that is in support of your project, where a key stakeholder that if you run into any problems or challenges or difficulties, people getting in your way, someone you can call and say, hey, sponsor, I've hit a roadblock. I need help from another department. They're not giving it to me. And the sponsor is the person that will go and knock on that door for you. Now, a sponsor isn't someone that's going to be involved with this project on a daily basis. The project manager is. The project manager is the one that will organize the team, schedule meetings, make sure agendas are set, help the team to develop action items. And when it comes to acting on those action items, that's really where the process owners and the team members will come into play. Now, the project manager should be able to manage and delegate tasks to multiple people. Projects are generally quite large in scale. But if you divide up all of the tasks and action items that you'll have for a particular project to several people over the course of several weeks, you'll find, especially if you're using some sort of a tracking system or a Kanban tool, that action items are getting done and getting complete because there's multiple people that have special skills in those areas that are tackling those problems. Selecting a good team is a critical first step to taking on a DMAIC project. So let's talk more about define. We did mention that constructing an effective problem statement is going to be the next very important step. Once you have your team together, we have to get this team either in a room or on a call, or we have to get the key folks of this team together and discuss what the problem is that we're all here to solve. The first step to doing that is to gain insight into the problem. So you can gain insight primarily by talking with subject matter experts in the particular area or process that you're working on, and with other key stakeholders. So your project sponsor is going to be a great person to talk to. Understand what it is about this process or this project that you're working on to improve really, really bugs your sponsor. Really, really bugs the people that are involved with a particular process. You may even talk to customers in this stage to understand exactly what the issues are that your customers are having with a product or service that they're not happy with, and that's why we are working here to improve that and increase that value to that customer. Gemba walks are another critical aspect in the step or the stage of creating an effective problem statement. You have to go and see the process you're trying to fix. If you don't understand the process, you cannot create an effective problem statement. The next step, analyze your problem statement. This is where we're going to gather up and identify the key performance indicators that are going to drive your project going forward. Some key performance indicators may already exist. Maybe they don't look good. They may be the reason that this project is underway. But we also may be missing other key performance indicators, other measurements that will help us to ensure that our project is on track and actually improving as we're working on it. Keep in mind that these key performance indicators should be something that you can manage ongoing, even after the project is complete. Now, if you have an idea for some key performance indicators, but you're just not really sure what those numbers actually are, go out and collect some data. Now, you're just kicking off this project. Don't spend all of your time collecting data. Just go and get a baseline. This is a good chance, you can just get a good rule of thumb just to get the wheels turning on this project. And once you understand what your KPIs are, you can put measurements in place. But if data exists, you have to go and get it and include that in your problem statement. The third step to constructing an effective problem statement is actually building it, writing it out, discussing it with your team. It can take 1 to 2 meetings to actually construct an effective problem statement. Now, these initial steps in doing that with your team are very important to ensure that everybody on the team is in line with the project that we are working on, that we all know that we are working on a specific issue, and ensure that we can define the scope of the problem and that we will not go outside of those boundaries. Your problem statement should be concise. Should be very clear about exactly where physically the problem is occurring. You should include your current state KPIs that you've gathered in this process in your problem statement. And it's important to articulate the magnitude of the problem that you're dealing with. To do this, you can incorporate those KPIs. You can even include dollars and cents. Nothing grabs an executive's attention more when you are trying to get buy-in for a project than telling them how much this problem is costing. Some tips when you are developing your problem statement. Don't speculate. Don't speculate about the root cause of the problem. Don't say what you think it is. Stick to the problem. What is the problem? Don't solution during the steps of creating your problem statement. Ensure that you understand the process. If you have to do multiple Gemba walks, talk to multiple subject matter experts, it's important to do so. Keep the audience in mind. Who's going to be reading your project charter and your problem statement? What resonates with them? What will get their attention? Right? What we are doing here is building a problem statement. 2 or 3 sentences that will capture the reader. Know your data. Make sure that the data in your problem statement is accurate. Now, if it's not accurate, it's okay to speculate. With roundabouts in the data, we can't get too far out of line here because we're going to have to back this up as we move through the DMAIC process. Don't attempt to solve the problem, right, or steer the solution in a way. We don't want the reader to think that we already have a solution, because if we know what the solution is, this wouldn't be a project. Let's look at some examples of some problem statements. This is a poor problem statement. Inventory levels are too high due to personnel shortages and must be reduced. Let's see how we can write this better. Inventory levels at the Metro facility are consuming space and increasing asset management time. Inventory levels are averaging 150 assets. These levels have exceeded the target of 25 assets 95% of the time since 2016. So again, we're still very concise. We've exemplified the magnitude of the problem by identifying the quantity. We've identified where our target should be and where it has been over an extended period of time. Now, keep in mind, problem statements can change over time. That is okay if the entire team agrees with the direction of where it's going. But if you have a strong problem statement and you're sitting in a group of people and you're discussing what person A or person B or person C thinks the problem is and what we should be doing to solve it, you can always go back to your initial problem statement and say, does what we are talking about right now directly affect our problem statement? If it doesn't, you can move the problem, the conversation forward. Let's look at another one. Human resources is taking too long to fill personnel requests, which is delaying IT projects. Let's see if we can improve on that. Recruiting time for IT contractors for the Client Services Department in San Jose is missing the goal of 30 days 91% of the time. The average time to fill a request is currently 55 days over the past 9 months. This delay is adding costs of $55,000 per month in overtime and rework. So, looking at the original problem statement, we were talking about human resources, right? We've zoomed in on that, talked about specifically recruiting as a function. And moreover, we're talking about IT contractors, as opposed to someone working in a different department or division. We've identified the location of the particular issue. And we know what our goal is, right? Our agreed upon SLA, and how often that SLA is being missed. But the most impactful part of the new problem statement is the dollar signs, this $55,000. Again, you show this to any executive, and they realize how much they are having to spend in overtime and rework as a result of not having the staff they need to get the job done. It will catch some attention. And again, if this conversation in your team meeting goes off a tangent here, and you're not talking about IT contractors, or you're not talking about San Jose, or you're not talking about the turnaround time to staff someone, you can just pull out the problem statement that everyone on the team agreed on and say, is what we are talking about right now directly related to our problem statement? Now that may spur, again, different conversations. You may decide that you should expand the scope of your project. Or you can use that as a tool to get your conversation back on track. Again, on the negative side, we just had too little information for the bad problem statements. You know, it's hard to take specific action when things are vague. Supporting roles, the things that we are going to need to do to achieve our goal, is not clear. And they've even speculated on root cause, right? These are things we all want to avoid. Things we do want to include in our problem statement is to make sure that we're clear on where it's happening, the magnitude of it, time frame, and cost. Good thing to think of is the who, what, when, where, and which aspect of the problem we are talking about. And finally, once you have your problem statement in your team, you're ready to construct your A3 project charter. There is no one single template for a project charter. You can make that any way you want. The main concept of a project charter is it is on an A3 sheet of paper. A3 does stand for the standard 8.5 by 11 sheet of paper that we are all familiar with. It is your ability to put your entire project on one sheet of paper. It's an important tool. So you fill out your project team members. You know, who are those important folks working on your project and their roles. Make sure that you clearly write out your problem statement on your project charter. If you can talk a little bit more about the current state if you want to expound on that, but it's also important to include what is in scope for your project and out of scope for your project. Again, critical tools for managing your project going forward. Let's move on to the measure phase. I will start off by saying there are countless approaches to measuring the sizes of problems. We can't go over all of them in this presentation. Two things we will cover, though, is the SIPOC diagram and a stopwatch. Before we dive in, again, lots of measurements approaches. Great opportunity here to start building on your process map and your value stream map. Not going to dive into detail on that here, as we will go into detail on how to create a process map and a value stream map in later sessions. Defects per opportunity, that's another great measurement tool. Your yield, depending on what type of product you're creating. Calculating your process sigma, understanding exactly where you're at as it relates to value and waste. Check sheets, great tools, capability analysis, gauge R&R. The list truly is endless when it comes to different types of measurements. But I want to talk to you today about two key things that we do in the measurement phase of the DMAIC process: completing a SIPOC diagram and using a stopwatch. So let's talk about a SIPOC diagram. So this term SIPOC stands for suppliers, inputs, process, outputs, and customers. When you're completing a SIPOC diagram, what you're going to actually do, quite literally, is fill out all 5 phases of this chart. You can start anywhere on your chart. A lot of people start right in the middle with their process. Let's start with talking about suppliers. So your suppliers are literally the folks that are bringing your raw materials into your process. Whatever that raw material is, the things that you need to do in order to do the process, right? And then you can actually start to manage those inputs, right? So your suppliers are bringing in your inputs and your materials. How are you managing them? What are those materials? Those inputs then move on to your actual process. Now your process is going to be broken down once it's within your organization into many steps. There can be hundreds of steps within a process. Again, we'll talk about how to actually create your process map in later sessions, so we won't dive into that here, but this is where that actual process goes. All processes create outputs. That's why they're processes, right? And eventually those outputs will be delivered to a customer. It's important to know what your outputs are, the quality of your outputs, understand what it is that you're producing, how you're producing them, and then how your customers are reacting to them, who your customers are. Breaking down the voice of the customer. We will talk more about the voice of the customer in later series here. Again, all of these are tools that will help us build our SIPOC diagram, which will be a significant tool in the measurement phase of the DMAIC methodology. Again, we will dive into process mapping and understanding our customers in later sessions. And measure. So we are talking about the next tool here, and this is process timings. Simple tool. It's a stopwatch. Stopwatches come in a lot of different shapes and forms. We all have a stopwatch on our smartphone. That's literally what I'm talking about. You press start, you time how long it takes to do something, you press stop when that thing is done. Now there's different ways of doing that. You don't actually need to use your phone. Sometimes a classic stopwatch is too difficult or cumbersome to get an entire concept of what you're trying to do. Sometimes you can do check-in or check-outs at certain points if you're dealing with physical products, or timestamps for digital products as they're moving through your services. You can do times that phone calls that came in and how long those phone calls were. There's lots of different ways to measure things, but the main point of using process timings in the measurement phase, the second phase of the DMAIC methodology, is to capture your current state. You want to know how long it takes you to do something. In Lean, our goal is to reduce waste to increase value to our customers. So what we do is make sure that we understand how much waste is in our process. How long is it taking us to do our process? It's very typical in a lot of organizations that 95% of the time spent working within a process or a value stream is spent working on waste or required waste. And only 5% of what we do is typically value add. Now those value add steps are very visible. And a lot of times what a lot of people want to do is spend time trying to improve those value add steps. You can see here from this diagram, if value add is already quite small of the total time that it takes us to create a product, our total lead time, there's not a lot of room for improvement on the value add steps themselves. If we focus on waste and reducing waste, there's a tremendous opportunity to reduce the amount of lead time in our total product if we're able to reduce the amount of times that our products or services are encountering Tim Woods. So again, a stopwatch, just making sure that we understand how long it takes us to do every step within our process, not just the value add steps, but also the waste, the waiting time, that transportation time that our products and services are incurring. We have the opportunity to significantly improve this. And it's important to get a baseline when you're starting the project, because what you will then do is compare the new time after you've implemented your improvements against the old time. And then when an executive says, hey, how much did you improve that process? You can say, well, it took us 5 days to do this process before. We implemented lean methodologies and we reduced our waste by 2 days. And now it takes us 3 days. If you time it, you have evidence to show how much you improved something. If you have evidence to show how much you've improved something, you can then put a dollar value to that. And again, nothing hits executives over the head better than a good old-fashioned dollar sign. Let's move on to the analyze phase in the DMAIC methodology. We've gone over define, measure, we are now in analyze. What we're going to cover here are some analysis tools that we can use to analyze our data and how we can complete an actual root cause analysis. So some basic tools for analysis. We have histograms, use the 5 whys, and Pareto charts. Histograms, essentially, we are going to have a comparison of a particular product, and we're going to compare the frequency that it's occurring over the amount of occurrences that we have. 5 whys is a tool where we essentially simply ask the question why 5 times. There's an old saying that says, if you ask the question why 5 times, you will get down to the root cause reason that something is occurring, period. That's all it takes, 5 times. And Pareto charts. Pareto charts is, again, it shows the number of categories that fall within a particular type of waste or project that you are working on. It's the classic 80-20 rule, right? So a lot of folks understand that 80% of your waste is only going to come from 20% of your particular product. So this tool helps us to visually see that. The curved line going from the lower left corner to the upper right corner is your running percentage total of occurrences. In this particular example, this is a Pareto chart of late arrivals. So what are all the reasons that you may come to work late? There can be traffic, childcare, public transportation, weather. And what this does is it counts the number of occurrences and does a running total on a percentage basis on the right-hand y-axis to understand, exactly where we are in this particular instance. So we can see here that just the first 2 issues, traffic and childcare, account for over 60% of all the waste that this particular process of arriving to work is incurring. The next tool we'll talk about in the analysis phase is the Ishikawa or Fishbone Diagram. Fishbone Diagram is an incredible tool for getting down to the root cause of the problem. I've used that term a lot, getting down to the root cause. Here's why. If you start attacking the symptoms of a problem, the things that flare up, and you attack it and you put it out, and then something else occurs, right? If you're not actually solving a problem, only dealing with the fires that arrive in your business every single day as a result, you'll spend all of your time fighting fires. And those fires will never stop coming up. Getting to the root cause of a particular issue, implementing new systems, processes to ensure that those fires stop happening, that's when we're truly getting into the core concept of lean. The fishbone diagram works like this. For starters, it's called a fishbone diagram because it looks like a fish with a lot of bones. You have a head of the fish. This is where you write your problem statement, the thing we are trying to solve. And in this stage, what you do is you gather everyone up that's on your team, all of those folks that you identified, qualified team members. and you ask them, hey, why do you think this problem is occurring? Little recommendation here, if you get a lot of people in a room and you start talking about these types of things, it's great for conversation. And it's good to just have an open conversation about something like this for, 10 minutes at the most in a big group of people. The sub-tool that you can use if you are meeting with people physically is pass out 10 Post-its to everyone and have everyone write out 10 reasons why they think this problem is occurring on their own. Put the Post-its on the wall and then discuss the Post-its. It's just a way of getting a lot of information from folks. That, by the way, is a way of doing what's called an affinity diagram. We discussed that in an earlier session. But if you spend your time in a meeting with 8, 10, 12 people, you'll wind up getting 2 or 3 issues when in fact there could be hundreds. When you're doing your fishbone diagram, there are some areas, right, that you can actually do. You don't have to follow all the bones on this fish, but there are some categories that a lot of issues will fall under. People, process, equipment, materials, environment, and management. So if you do hit a roadblock with your team, this is, again, just a good way of help guiding them. Well, what is it about this problem that we think people are creating? What kind of people do we have? We got customers, we have employees, we have people in other divisions or departments. What are they doing that's helping to contribute to this problem? What is it about the process that's contributing to this problem? Are there too many sign-offs? Do we literally have to move things around? Is there a lot of transportation within our process that's slowing down or creating this problem? What's going on with the types of equipment we use? Let's list out all of our equipment. Is it old? Is it new? Is it obsolete? Is the software up to date on it? Are the materials we're using the right materials? If our yields are too low, that can be a huge problem. Is there something about our environment? Is there an issue with humidity levels? Is it too hot, too cold? Are our employees unhappy with their environment? Is our product like the environment that it's working in? Management. A lot of times, managers require a lot of approvals or sign-offs. Are they creating bottlenecks in the process? The fishbone diagram is a great way. You write the problem in the head of the fish, and you just have people write down contributing factors to that problem. Oh, side note, if you're not meeting in person, you're doing a virtual team, what I generally do is I ask everyone to send me an email list of 10 things separately on their own. And then what you do is you gather up all of those emails and you categorize them and put them in an Excel spreadsheet and run a histogram on those issues so that you can visibly see what the key issues are, the things that everyone agrees with. Because if you ask 10 different people to fill out 10 different ideas, you got 100 ideas to work on. What you do is you can take a look. Now, here's the thing. A lot of those people are going to have the same exact issues. So you see which one occurs the most, and that's where you start. We're going to talk more about that in the next part of this session. Now, in the next slide here, what we're going to do is we're going to watch a video of DMAIC in action. When you're watching this video, keep an eye out for the 5 whys and root cause analysis when they're actually working to solve this problem.
Sometimes the difference between jumping to conclusions and finding creative solutions can be the difference between night and day. To shed some light on the subject, let's spend a quality minute with Howland Blackiston.
In Thomas Jefferson's time, patriots defended our nation's capital from the invading British. More recently, the Park Service had to defend the Jefferson Memorial from invaders of another sort. The stone in this building was crumbling. What could be causing this decay? It turns out that it was actually the frequent washings of the stone that was creating the problem. The reason they washed it so often was because there were so many bird droppings on the building. Then they asked themselves, well, why are there so many birds in the building? There's an abundant food supply. hundreds and hundreds of little fat spiders. So then they asked themselves, why are there so many spiders? The spiders were attracted by the midges, thousands of tiny little insects. So they asked themselves, why are there so many midges? Every evening at dusk, millions of these midges emerge in a mating frenzy. Also, at the same time every evening, the National Park Service turns on the powerful spotlights that illuminate the monument. Well, the excited midges are attracted to the light. The solution? The Park Service has delayed the daily lighting of the structure to 1 hour after sunset. The midge population is down 90%, they've broken the food chain, and there are less frequent washings. So, make sure you're working with all the information and get to the true root cause of the problem. The results can be literally night and day. For Duran Institute, I'm Howland Blackiston with another Quality Minute.
So this is a great study completed by the Duran Institute, incredible organization for process improvement. 2 minutes, we got to see the entire DMAIC process unfold. It's hard, it can be hard to think when you go to see something like a monument and you see the stone crumbling, that the light is causing that. But if you work through the problem, if you ask yourself why are we doing this? Why are we doing that? In any situation, if you get down to the root cause of a particular issue, you might be shocked at what is actually causing a particular problem. It's a good chance to think, about some improvements that you do every single day within your job or your organization. We're constantly thinking of ways to improve, and we're constantly doing it subconsciously or consciously or actively working on projects. Is what we are doing a reaction to a fire that's been occurring? Or is the solutions that we are working and putting in place actually solving the root cause of the problem to ensure that it will never happen again? Just some food for thought, and that actually completes Section 2A, Part 1 of the PDCA and DMAIC process. Please follow up on Part 2 so that we can finish the DMAIC review for define, measure, analyze, and focus on improve and control in the next part. Thank you.